We have this audiogram visualizer, which is essentially an interactive hearing test where you can test your hearing. It will then show you the audiogram. Now we would like another tool that will be essentially a hearing aid where you could import the audiogram and it will adjust the hearing aid parameters accordingly based on your audiogram. So that's the idea for the tool. Now we had Claude generating some code for us based on the instructions that we generated in ChatGPT. Originally we're telling ChatGPT to not generate any code. Just generate the instructions, telling it that we have another developer doing the coding for us. Claude did generate the code. It ignored the instruction of separate files and placed everything into one HTML, which was a bit odd, but okay. Generally, we're testing this code last time. It's working fine, but yeah, it's not great. ChatGPT actually also generated the code and we'll be comparing the two, seeing what difference does it make. So again, we have this hearing test. It's an interactive hearing test, real-time visualization. You can test your own hearing. It will generate this audiogram. And now the idea that you could import or export it from this tool and import into a hearing aid simulator, and it will adjust the frequency gains for you accordingly based on your audiogram, and then you could just use it, potentially using any earphones that have a microphone, any earbuds. But yes, this is just a simulation, so shouldn't get ahead of ourselves. So again, Claude did this code, but then we also generated the same thing using ChatGPT, and this will be hearing aid version 4 or 5. Yeah, we could have different presets, different hearing types, because if I export my own audiogram, my own results of a hearing test, it will obviously look different than somebody else's. So we could have a few different types of preset audiograms. So preset hearing conditions, which we can have like normal hearing and some high frequency hearing loss, low frequency hearing loss, things like that. And let's actually deploy, see what we get. Okay, can load default audiogram. Let's see if I get any errors. Okay, so the audiogram was, the default one was loaded. Eventually you'll be able to also select your own audiogram as well. Now we don't have sample audio yet, but we can use the microphone. Okay, that looks promising. Everything seemed to work correctly. Supposedly the default audiogram was loaded. We're able to use the microphone. I see the sound visualization, but it's not clear what's the volume control is doing, because I thought I meant to be able to hear myself. So essentially, if the sound is going to my own microphone and I'm changing the volume control, was the idea that the sound coming into the microphone will be amplified? Can you explain? Or is there something missing in the code? Since there is a disconnect between visualization and actual amplification. Let's break it down. What's happening in the current code? The microphones pre-recorded audio input captured, visualized. Okay, the volume control currently doesn't affect audio playback. Okay, what's missing? To match your expectations. Hearing the amplified microphone input, the app needs to route the audio output into the speakers or headphones. Okay, after processing the sound, it should be sent. Okay, so why didn't you do it already? Setup gain. Okay, can we actually do rapid fire questions about this code? So I'll be asking a question, you will be answering quickly. Can you give a one sentence summary of what the code is currently doing?
The code captures audio input, microphone, or pre-recorded, visualizes the frequency data, but doesn't route or amplify the sound for playback yet.
Okay, so that just wasn't the code was just not generated in its complete form. Is that correct?
Yes, that's correct. The code was incomplete. It visualized the audio, but didn't include the necessary logic for routing the processed sound back to the speakers or applying amplification via the volume control.
Okay, just a quick question. Did we have it in the original instructions for the web application development or not?
No, the original instructions focused on visualizing sound and adjusting parameters, but didn't explicitly mention routing the audio back to the speakers or amplifying it for playback. That part was implied but not directly specified.
Okay, so with the application as it is, based on the image I attached earlier, what is the volume control meant to do?
As it stands, the volume control in the current application is non-functional because it isn't connected to a gain node to adjust the sound's amplitude. It's essentially a placeholder without any real effect on the audio.
Okay, now the main question is, yeah, we'll have to change this, but the main question, so when we're loading the audiogram or choosing one from file later on, but currently when we're loading the default audiogram, what parameters should be changing in the hearing aid simulator based on that audiogram?
When the audiogram is loaded, it should adjust the frequency-specific gain parameters in the hearing aid simulator. This means the audiogram's frequencies and corresponding gain values should be used to amplify or attenuate specific frequency bands in the audio signal, simulating how a hearing aid compensates for hearing loss at those frequencies. For example, if the audiogram indicates more gain is needed at 2000 Hz, the simulator should amplify that frequency accordingly.
Okay, so quickly, how would we modify the code accordingly? Can you not include any code in your response, just language-based, just text-based?
To modify the code, you would first parse the audiogram data to extract frequencies and their associated gain values. Then, create a bandpass filter or equalizer for each frequency band using biquad filter nodes in the Web Audio API. Adjust the gain of each filter based on the audiogram's gain values. Finally, connect these filters in series or parallel between the audio source and the gain node, ensuring the processed sound reflects the audiogram's frequency-specific adjustments.
Okay, so what extra chart would you recommend on the front page? A hint, I'm thinking of the original audiogram and overlaid are the settings. So if we have a chart, then the chart should be decibels versus frequency, and then we are plotting the original audiogram, which is the default audiogram in the JSON file at the moment, but then overlaying on top the same chart the settings for the hearing aid within the same for each of those frequencies. Can you explain it in a better way?
You could add a chart showing decibels y-axis versus frequency x-axis, where the original audiogram from the JSON file is plotted as a baseline. Overlay this with another line representing the hearing aid's current gain settings for each frequency band. This would visually compare the user's hearing loss profile with how the hearing aid is compensating for it, giving an immediate and intuitive understanding of the adjustments being applied.
Yeah, including noise reduction is important for a hearing aid, isn't it? We might look at it later on. Yeah, tooltips are always handy, but we would like the core functionality first, and yeah, which is the web app that simulates a hearing aid by adjusting audio input. Yeah, you can choose between the live microphone or pre-recorded MP3 file. Okay, now the question is, do we give it to Claudette? Okay, let's give it to Claudette. It should be with Claude we're doing a single shot. So we're asking all the necessary. Can you generate all the necessary script for the different files as outlined below? Okay, so we have all these instructions from ChatGPT 4.0, and we're gonna give them to Claudette. Yeah, don't worry about future things, but I don't know, I'm not that familiar with Claude actually. Assuming it's okay to use 3.5 Sonnet. That's the default thingy. Yep. Okay, index HTML. This will be a 6th or 7th version of this hearing aid simulator. Hearing aid simulator. Yeah, the main question is, which one's better, ChatGPT or Claude? Let me look at what Claude generated first. Yeah, so Claude is just generating way more code. Hopefully there is a good reason for it. So ChatGPT generated only 80 lines of code and Claude almost double, so 150 or so. Wait, and it didn't finish. Okay, that's the problem with Claude. That give me a timeout. It did not finish. Yeah, it's actually generating the whole thing now. Yeah, so that limit means just that specific response for that single prompt was too long. Okay, it's a whopping. Will be hard to test. Did some testing. Don't know why it's so long. Wasn't meant to be that long. 551 lines of code, and it also needs another JavaScript. Wiki, there's something wrong. Something wrong. The Audiogram JS is missing. That's right. Audiogram JS. Audiogram JS. Yeah, Claude is not great, but at least I don't know how to use it properly. Okay, the controls meant to be for each specific band. There's no error messages, but the buttons don't seem to do anything at all. Nothing is being displayed in the charts. Using Chart.js should be fine. Okay, that's the 11th version. And yeah, while it's generating, go check out the website. You'll be helping that way a lot. Any comment is highly appreciated. Okay, it's the 15th version of app.js. Let me provide a complete corrected version. Yeah, I won't be able to generate the whole thing. Okay, we actually have something. So now we can hear ourselves. The audiogram looks super weird. It's been loaded. Yeah, there's no pre-recorded files at the moment. This should increase the volume and it doesn't actually do it. That audiogram doesn't look right. Using our own microphone. This volume meant to increase the frequencies based on the audiogram we cannot hear. So that yeah, that's actually working. It's doing something useful. So this will be version hearing aid version 5. Yeah, we'll keep testing it. Eventually make it available for you as well to test on this side. Go check the other tools on the website. Don't forget to provide your feedback, and I'll see you next time. Bye.